Lab 2 Lines of Charge by Pablo Vila. The purpose of today's video is to produce a computational model of two charge tapes exerting a force on one another, and we do this by using GlowScript. Next, we want to calculate the electric force required to levitate the tape, and we also want to determine the accuracy of our calculations in the first lab compared to the lab we are looking at right now. The main lab results we'll see by the end of this video is 1. The tapes are repelled by each other. 2. Lab 1 tape charge was found to be 1.496 e to the negative 8 coulombs. 3. The lab 2 tape charge was found to be 2.93 e to the negative 8 coulombs. And finally, what we'll see is the percent difference from the original model to this model was almost double the difference, so about 195.7% difference. The main physics ideas that are present in this experiment are 1. Newton's second law, force equals mass times acceleration, and we need to know the gravity acceleration, which is 9.81 meters per second squared. We also need to know the electric field for a point charge, and this is found to be the equation on the right, 1 over 4 pi epsilon naught times q over r squared r hat. We also need the electric force for the point charge, which is found to be F equals q, the charge, times electric field net. This lab builds off of lab 1, so it is important to review what we discovered in this portion. In lab 1, we found the initial conditions to be tape length equals 0.214 meters, tape width was 0.02 meters, the mass was 2.14 e to the negative 4 kilograms, and the distance between the two tapes when repelled was 0.031 meters. And the system was found to be tape B, while the surroundings were tape A and everything else around it, including the Earth's gravity. The main lab results we found in lab 1 were electric force, which was 2.099 e to the negative 3 newtons, and we also found the charge of one piece of tape to be about 1.497 e to the negative 8 coulombs. Next, we'll cover the first part of the code in lab 2. In the first part, we defined our constants such as charge of electron, proton, and 1 over 4 pi epsilon naught. In the middle of this picture, we also defined the initial tape values that we mentioned in the previous slide regarding lab 1 experiment. And in line 27, we defined the accuracy percentage difference as a decimal, which again was about 196.6% difference. Lastly, we calculated Q, the charge of one piece of tape. In the second part, we defined the electric field function as a way to calculate the electric field of a point charge, and this was used using the normal equation we're all familiar with. In line 55, we defined a line charge function as a way to create a visual for us to understand what is going on. In the last part, we called the line function twice to create a row of red and blue particles as shown in the picture, and we applied the principle of superposition on the for loops to find the net electric field by the tape. In the end, we found that F gravity was equal to F electric, and finally, at the very last line, we printed all our values to understand what was happening. Comparing the results from lab 1 and lab 2, we can see that some of the similarities include the force of gravity and electric force are equal in magnitude but opposite in direction, and this can be seen on the models, which explains why the bigger arrows, are equal in size. Next, we calculated the electric force and charge the same way that we're familiar with using Coulomb's law. The two main differences that we found in the lab was that lab 1 models tape as a point charge, while lab 2 models tape as a rod split into point charges. And next, we find that lab 2 is more accurate because of this. What if you had modeled each of your tapes as a single point charge, like in the previous lab? If we had done this, then we would have gotten the same results as we did in lab 1, but because we decided to model our results as a line charge, we almost got double the difference when looking at the charge of the tape. In the point charge, we got 1.496 e to the negative 8 coulombs, while in the line charge, we got 2.93 e to the negative 8 coulombs. So why do these estimates differ so much? Which value is more likely closer to the real value, and why? The system is calculated in different ways due to the different models. The line charge is closer to the real value because it has more step sizes, and more step sizes are more accurate to the real value. Think about Riemann sums. And the point charge is not realistic either. In conclusion, we see that the line charge is more accurate but harder to calculate due to the smaller step sizes. We can also estimate electric field and electric force with Coulomb's law. Some potential sources of error include air resistance or other external forces that were not taken into account. The tape charge might not have been evenly distributed, which would have skewed our data for lab 1 and lab 2. And going back to the lab 1, there was a chance that I might have used excessive contact with my hand, which could have skewed the data for the electric field and charge.